Hi guys, sorry I'm not there. I'm at a choir thing, so we are going to go ahead and get started on this activity. So you should have this right now, exponent investigation number 3, negative and zero exponents. This is the investigation where we're going to finally learn how do we deal with those pesky negative exponents. Okay, so the instructions say complete the following tables using the exponents to generate equivalent values and find patterns. Okay, so basically what we're going to do is we're going to start at the bottom here, and we're going to figure out what are each of these values. Okay, so obviously we know that 2 to the 1 power is 2. It's pretty straightforward. 2 squared, 2 to the 2nd power, you guys probably know all this already, that it's 4, right? And 2 cubed, 2 to the 3rd power, we know is 8. It's pretty straightforward. 2 to the 4 power, we have 16, then 32, 64, and then I believe it's 128. Let me double check that real quick. Yeah. So that one's pretty easy, pretty straightforward. But now the idea is, what is the pattern? If I were to just look at this column, what pattern am I looking at? Okay, so as I go from 2 to 4, what am I doing? As I'm going from 4 to 8, what am I doing? 8 to 16, 16 to 32, 32 to 64, 64 to 128. What am I doing to each number to get the next number in the row? Think about that for a second. So, hopefully you guys have figured out that you're just multiplying the first number to get the second number by 2. I'm going 2 times 2 is 4, multiplying by 2 to go over there. So that's what you're going to write here. Multiply each number by 4. Sorry, each row by 4. And by 4 I mean 2. Multiply each row by 2. Okay, awesome. Okay, let's move on to the next one over here. So we're going to go ahead and fill out this. So go ahead right now in your own time, fill this out, and I'll do my own thing while you fill it out. Use your calculator, use your brain, whatever you need to do, fill this out, and you're going upward. Okay, so if you guys need more time, go ahead and pause it now for everyone to fill it out. Pause it now, and then we'll talk about it when you're done. Okay, so hopefully everyone has it filled out, and we're looking at something that looks like this. As you go up, you see the numbers increase a lot, and we got to figure out what exactly is the pattern here. Same as before, what's the pattern as we go from 5 to 25 and from 25 to 125? What am I doing to each of these rows to move up the pattern? You probably have figured out that it's the same exact pattern as before, but with a small change. This time we are multiplying each row by, you guessed it, 5. We're multiplying each row by 5. Pretty cool. So now that we've done 2 of these, I want you to take a look. So we're multiplying each row by 2, and then we're multiplying each row by 5. Is there anything going on? Why are we multiplying this one by 2 and this one by 5? What's really going on here? Where are we getting this 2 from? Where are we getting this 5 from? Well, hopefully you guessed that really the reason we're multiplying this one by 2 and this one by 5 is because that's what the bases are. Here the base is 2, so we're multiplying each one by 2. Here the base is 5, we multiply each one by 5. So what I'm going to do real quick is I'm going to add this in. 2 is the base. And as many of you know, it's all about the base. And in this case, that's very true. That's really bad handwriting, but whatever. Okay, the base. Let's go on, move on to the next one. So go ahead and fill this out. You're going to fill out what are each of the powers moving upward, and then you're going to try and come up with the pattern, okay? So pause it here, and you guys work, and then we'll come back when you're done with this one. Okay, so hopefully you guys have something that looks like this. We know that we're multiplying each row by 3 as we go vertically. We know that each of the exponents are represented there. And we know we're multiplying by 3 because the base is 3, and we can see, hey, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, etc. as you go through there. Okay, last one. Last one, we're doing the tens. Okay, so go ahead and fill this out. You're going to fill out your row vertically, and you're going to identify what you think the pattern is. Do this now. Pause it if you need to. Okay, hopefully you guys got something that looks like this. 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000, all the way up. And to go from 1 to the next, we're multiplying it by 10, because that is what the base is. So 10 times 10 is 100, 100 times 10 is 1,000, 1,000 times 10 is 10,000, etc. Okay, now we're going to get to sort of like, why are we doing this? What's this all about? So it says, look back at your tables in question 1, and look at the equivalent values column and look up the column. What pattern do you notice for each table as the exponents increase by 1 each row? Write down the pattern for your table. So we already identified it here. What are we multiplying each row by? We're multiplying each of them by the base. So the sort of the pattern that we're going to identify and write down in words is pretty straightforward. You need to multiply each row by the base. Of the exponent to find the next row above. Okay, pause it here if you need to, but that's what we're doing. We're multiplying each row by the exponent to find the row above it. Okay, when you're done with that, go ahead and flip it over and we'll do the backside. So now we're gonna go in reverse. So instead of starting at the bottom and moving up, we're going to start at the top and move our way down, okay? And you'll see that as we go down, we're working our way into negative exponents, okay? So first up here, we have 2 times 2. We already know that's 4 from the previous page and just from our brains. 2 to the second power is 4. 2 to the first power is 2. 2 to the 0 power, well, if you need to do these, you can use your calculator. Decimals are not okay. You need to use fractions. So as you go through these, you're gonna if your calculator is probably going to give you decimals. You just have to turn those decimals into fractions. Okay. So 2 to the 0 power. Well, that your calculator will tell you that's 1. 2 to the negative 1 is 1/2. Your calculator probably says 0.5, but you know that's 1/2 is a fraction. 2 to the negative second power is 1/4. 2 to the negative third power is 1/8. And 2 to the negative 4 power is 1/16. Okay? So as we go down, as we look down here, what are we doing to the 4 to get the 2? And then the 2 to get the 1? What's the thing we're doing to all of these? We're doing one thing to get from move our way down the rows. And those of you who kind of figure out, well, if going up we were multiplying, then that means going down we're probably going to be, and you guessed it, we are dividing. So we're divide each row by what? What are we dividing each row by? 2. We're dividing each row by 2. Okay, let's take a look over here at the next one. Okay, well, we already know that 5 squared is 5 times 5 is 25, and 5 to the first power is 5. We kind of already learned that, hey, anything to the 0 power is 1. We already talked about that in class. Okay, 5 to the negative 1 power. Put that in your calculator. You actually get 1/5. 1/5. 0.2. Okay, and then you put this in your calculator. You're going to have to turn it into a fraction. 1/25. And then the next one we have 1/125. And then 1/625. Okay? So what's the pattern we see? How do we get from 25 to 5, and then 5 to 1, and then 1 to 1/5? What are we doing each time? As you probably know, the patterns are pretty straightforward. Yeah, we're dividing each row by 5. So let's take a look at these two again. We have divide each row by 5 and divide each row by 2. Where are we getting those 5 and those 2's? Same as before. It's from the base. So go ahead and write that in. Okay, we know this is the base. And this is the base. Okay, awesome. Okay, now on your own, go ahead and do the next 2. See what you come up with, okay? Do the next 2 on your own. Pause it as you need before moving on, okay? And we'll catch up here with each other in a second. Okay, if you're done, this is going to look something like this. Okay. Pause it here if you need to, just to compare. We are dividing each row by 3 on the left one and dividing each row by 10 on the right one as we move down the column. So we're kind of seeing that negative exponents give us smaller and smaller numbers. Right? Negative exponents giving us smaller and smaller numbers. Okay? I want to point out something here. If you look at like 10 to the 2 is 100. What's 10 to the negative 2? 1/100. I see 10 to the 1 is 10. 10 to the negative 1 is 1/10. Interesting pattern. Over here I see 3 to the 2 is 9. 3 to the negative 2, 1/9. 3 to the 1 is 3. 3 to the negative 1 is 1/3. Interesting. this pattern holds up. It's pretty interesting. Okay, so look at the four tables. What are your values? What's the value for 2 to the 0, 3 to the 0, 4, 5 to the 0, and 10 to the 0? What does this tell you about x to the 0? So when it says x to the 0, that means anything to the 0, or a variable to the 0. Well, we've already learned this. What is anything to the 0? Well, we know that the values are all 1. That means that x to the 0 would also be 1. We've already talked about this, but now we kind of figured out why. Okay. Now it says, look back at your table. We have 3 to the negative 2 up here, right? 3 to the negative 2 is 1/9. Is 3 to the negative 2 equivalent to 3 times negative 2? Are these the same thing? 3 to the negative 2 and 3 times negative 2. Do the rules of multiplication with a negative number apply when the negative number is an exponent? So we know that when we multiply a positive times a negative, the answer is a negative, right? But here we see that 3 to the negative 2 is not negative. It's positive. It's 1/9. It's positive 1/9. But we know that 3 times negative 2 is negative 6. So they're not equivalent. They're not equivalent. They are not. So that's what we're going to write. They are not equivalent. So when we multiply positive times a negative, we get a negative number. But here we find that when we have a negative exponent, the result is not a negative number, right? So the rule does not apply. Okay. Next question. Feel free to pause at any time if you want to rewind, pause, or you're slow or whatever. That's totally fine. So write a rule to summarize the property of any number to the 0 power. Well, we already know this. Any number to the 0 power is what? Is 1. Okay? Last thing before we're done. Write a rule to summarize the property of negative exponents. What effect does the negative exponent have overall? Well, that's what we talked about earlier. When we have 2 to the 2 and 2 to the negative 2, if you look at them, you have 4 and 1 over 4. When you have 2 to the 1 and 2 to the negative 1, you have 2 and 1 over 2. Same thing over here. It seems that if you have a negative version of an exponent, what do? You have 25 becomes negative 25. Sorry, 1 over 25. What are we doing when we take a positive exponent and we look at its negative counterpart? What's happening? What do we see? What is it called when you, well, we know that 25 is actually 25 over 1. And this is 1 over 25. What do you call it when you flip a fraction? What's it called when you flip a fraction? We've learned about it earlier this year. It's a fun word. Okay. Hopefully you figured it out. You know it. What's the word? The word is reciprocal. The word is reciprocal. When you flip over a fraction, it's called a reciprocal. Okay? So that's what we're going to do. Whenever you have a negative exponent, you end up using the reciprocal. So what's our rule? Our rule is to find the value of a negative exponent use the reciprocal. Okay? To find the value of a negative exponent, use the reciprocal. That's the trick. The trick is you use the reciprocal. Now, how does that apply in our solving of these, or not solving, but simplifying of these expressions? Well, we're going to find out tomorrow. We're going to teach you the rule and teach you how to actually apply it when we're dealing with negative exponents, but just know that it involves the reciprocal. Okay, thank you for listening. Feel free to pause, rewind, play again, any parts that you need. And that's all. Thank you very much. Have a great day.